Everyone, my name is Matt. I'm a consulting SE now in Canada. I've been at Splunk for about 5 years now and have been a Splunk user for a long time prior to that. Good to see some familiar faces here. Would have seen some of the Splunk side probably more like Smitty was saying a little bit more frequently up till now, but good to catch up with you virtually before the break. Just wanted to throw the video on and say hi before I dive in. I usually don't do much more than I like to pride myself on actually just walking you through something hands-on. So I don't do much presentation of an actual slide deck, but I'm going to walk you through the Splunk Operator as a context to start larger discussion if you all like. Because Kubernetes is a large ecosystem and topic, and we could end up in a lot of places. But I think the operator is a good thing to talk about because we are currently amidst public beta. The work on the Splunk Operator has been going on for almost a couple of years now, but it's really started to pick up since Conf 2020. And the work that's going on now is some of the more impressive stuff. So it'd be good to see a lot of Splunkers, even if your environments are not adopting cloud APIs or Kubernetes yet. It would be good to get involved. As you'll see, Kubernetes is just one piece of a larger story, and kind of when I show you hopefully something cool today, it'll show that it's actually, when done right, it won't even be what you're talking about at all. In fact, it'll just be something that runs underneath the hood while a nice big and prosperous Splunk environment is running along. Is kind of the idea. So I'm going to switch off my camera now. So nice to see you all. The bandwidth is a premium these days. So I'm going to switch over to actually just sharing my screen. So as I do that, what I'm going to do is start with something very familiar. Just share it all, YOLO desktop. No, don't start there. We're not going to go to the weeds just yet. So let me grab some bandwidth here. Okay. So I'm going to take you through the Splunk Operator. The Splunk Operator is an operator that is that is built using a pattern that was made popular a couple of years ago by a company called CoreOS. They are basically working with OpenShift these days. And essentially what it means is, the best thing to do here is just to orient. I am the actual public project. Again, it's in a beta, but it's public. So it just means you can join us here and take part in it with the code right away. And also provide any feedback or any findings that you have, or any things that you might want to share as a Splunk administrator or somebody who's trying to adopt Splunk or use Splunk, and might want to adopt some of the feature set that is provided with this project. I'm in the actual repo itself. So again, public stuff. And I'm just going to center around the docs folder here and just walk through a couple of quick things, because I think this repository does a great job of kind of giving you an up-to-date view of where we're at and kind of hopefully where we're going. So before I dive in, super deep, if you have any questions or any kind of items, if someone could watch the chat and just interrupt me at any time, I'd like this to be kind of back and forth. I'm going to kind of level set and show a couple things, and then we can stop. And I'd love to just hit the lab with you, show you my lab, let you all kind of just let me know what you would be interested in seeing, and we'll go from there. So feel free to stop me anytime. So yeah, Splunk Boston, Splunk user group, good. Thank you for having me, by the way. Boston's a place I miss traveling to for sure. I mentioned Red Hat and OpenShift right off the top. I've done some work down there as well that relates to this. So shout out to that team there. So here's what I'm going to show you. I'm going to show you a Splunk Operator. Oops, sorry, wrong repo. That's a good start. I'm going to show you the Splunk Operator as a user of the Splunk Operator. I've been using the Splunk Operator now for over a year, and I'm going to show you an environment that's been running for a year, serving a Splunk instance to splunk.matimo.io. So it's my actual, public instance. It's down right now because I broke it for you. So we can go take a look at it because it's fun to look at broken things, in my opinion. So, but just know that this environment is being served to the internet as my lab on Kubernetes, and it was built by the operator. So we're going to go in there and have a look at it, maybe troubleshoot a little bit with some of the stuff I have, and talk about what does it mean and why is it interesting. So before we get too deep, there's a FAQ on the repo, and I bring it here only because I wanted to show you kind of a great kind of excerpt to the positioning of why is anything that Matt is talking about right now relevant to me, especially with the Kubernetes overload going on. It's just like the idea when you hear the word, it just kind of can shut people's minds off sometimes even. So let's level set here. So if we go to Splunk supported operating systems, Splunk does support a containerized version of Splunk D. And so as you'll see in the actual operating system requirements, there are growing support, and this was work we laid way back in 2019, I think, or 18, when we knew that the first step to getting to something like a advanced orchestration environment or a cloud environment like Kubernetes would be to have a a container image that we could that could seed that entire experience. And so what I'm going to be showing you today, it walks the line between technically feasible and fully supported. So I just wanted to call out early that the containerized computing platforms supported by Splunk start with the Docker image. I'm not going to go super down into the Docker image. All I want to point out is that for all intents and purposes, it just becomes a supported container that you pull off the shelf, and it's Splunk D. Okay, so that is fully supported, the container. Now, what I'm about to show you and where the operator goes is it utilizes the container to automate it. And so you'll see it's kind of like a layer on top. So you don't need the operator to run Splunk in Kubernetes, but as you'll see, it is striving to become that kind of autopilot where in the operator pattern, which I'll go into in a moment, we can encode the knowledge to run Splunk well into the actual platform and allow users to learn that way rather than trying to encode it into a human brain, right? So, which is still important, but is I would say is less scalable than making the thing drive itself. Any questions on support for the Docker image from Splunk? Because that's always a hot topic. So I'll take a quick breath and a little gulp of water before I jump into how I take this image and go and use it in Kubernetes. Any questions? Just didn't want to lull you all to sleep. So, okay, don't be shy. So I'm going to take that image. Now, I'll pause there and say, and jump off from that and say, a Docker image is not enough. That's like still very similar to Splunk handing me a tarball. In fact, a Docker image is a tarball, right? So at the end of the day, what we want to do is basically look at, okay, now if I take that, what can I do with it to run it in an enterprise fashion? And so why would you ever build something like a Kubernetes operator? And so again, there's a little FAQ here. I'm not going to read you the doc straight, but I just want to show you there's somewhere to come back to and review. And by the way, I'll go through a lot of material, but I'll summarize it. I'm going to host it on my GitLab, which is also hosted in my Kubernetes environment we're going to play in today. So we'll don't try to like keep up or I would love to, if you have questions or whatever, don't hesitate to if you get lost, just let us know. So the operator, what is it? Well, the operator, what am I talking about? What is this all about? Well, what it is, it's a pattern to allow software development to happen where the builder of the application builds the automation and the care and feeding for that application into the application such that the human has a lot less a huge reduction in toil. And that is one of the big deliveries, right? And the aims of Kubernetes in general, or DevOps in general. But the point is again, like I said, we're trying to go from a place where you get handed, a hammer, and more something where somebody comes in, builds the house for you, right? There's great documentation on like the motivation and the idea behind it, but the key here is it's laid out very well here. Operators are a lot like installers for the cloud. They enable developers to package all the components of the app and deploy it across a massive fleet of infrastructure. And it allows developers to automate that operation and allow the developer team to own that application without having to pass that on to the human user. Okay, and so that sounds a lot like using cloud, right? And yeah, absolutely, this is a cloud pattern, right? But this is a pattern that can extend from the cloud into something like the private cloud, or run something on a public cloud on your own, right? So, and again, there are lots of other ways you could do this, right? There are, you could use Helm, you could use, pure tooling that you already have, et cetera, et cetera. But this is a pattern that is very agnostic and allows us, even today in the early days, to look across all cloud vendors and have a known API that we can use and leverage when we walk into that environment to deploy Splunk and otherwise, right? So that's a little bit on the operator. Again, it's a concept where you create these custom resources so that a cluster knows or extends its knowledge about a resource. So let's take a look, right? Let's take a look at an example before we go any further. So here is my lab. I am sitting in, and actually, let's not go this way. I know we're all nerds and we could go from the CLI, but I want to show you it in a couple of cool ways. So this is my lab. You can see my lab right here is a single node box that runs on quite a nice piece of hardware. It runs on a 24 core box that has been heating my basement up here in Canada for a couple of years now. And it's run faithfully though. And so you can see that I have a single node where I'm running my Kubernetes cluster. This is a view of my cluster in Splunk Infrastructure Monitoring. In my cluster, I have a bunch of things running. And so before I go show it to you from the command line, I just wanted to show it to you from here, where I can show you that I have all the workloads that are running in my environment monitored. So we'll come back and look at some of that and how that translates. I also have it in Splunk, of course, right? And so from a less infrastructure point of view, and maybe from a more logical view, my service here, micro K8s, which is my Kubernetes cluster, is made up of a single node and has a bunch of namespaces on it where we run applications. And so what I'm going to do is just use this as an anchor so we can come back to it so we don't get too lost in the sauce, right? Because the idea is not that we go down. I mean, the idea is that we go down and play in the weeds, but to remember that it remains anchored to the point that we're just trying to run Splunk automated or at a large scale in a cloudy way, right? And so this is a cool dynamic search that will update if I create or destroy things in my environment. So it's just a good way to level set what we're about to dive into on the command line. So I have a Kubernetes cluster made up of one single big compute node that has a bunch of cool things we can play with today. And again, based on your questions, we might go into some of these cool Easter eggs in here if we want to. We'll see. But just so you know, there's a lot of surrounding stuff that we could get into. But let's start with the Splunk operator, which I deploy a Splunk instance with in the Splunk dev namespace. Okay, so I'm going to jump down into that node now, and I have CLI access to that cluster as well. So from an administrator point of view, the cluster looks like this, right? So I have one node, right? It has a bunch of namespaces, right, with applications running in them. And this maps nicely to the concept of things like Splunk indexes or business lines, right? This is essentially what you'll run into in an enterprise environment, is that these would be app teams or the like, right? Now, if I go into the Splunk namespace where I am running the actual operator, I just updated it. Actually, I'm going to show you how I'm going to actually try to get this working before we get off the phone. But basically, I have updated this Splunk operator, which is now you're actually visually looking at what the operator actually is, which is just a Kubernetes pod that runs in my cluster and teaches Kubernetes how to speak Splunk. And so, for example, in my cluster, because I have installed the Kubernetes operator to my cluster, I am able to do things like get standalones. And now Splunk has become a native resource in the Kubernetes environment. So I have a standalone instance of Splunk called dev. Okay, and it's pending, it's broken, and that's why my website is down right. Well, not my website, but Splunk is down right now. Okay, and we're going to try to update that to 8.1 here today. Hopefully, if we could play a little bit, I'll stop babbling along, and we'll just see where we can get. Now, in this same cluster, I have that Splunk instance running and I send data to it from the cluster itself. So I also want to show that in case this is boring anyone and anyone wants to vote to talk about data collection out of Kubernetes instead. But you got to have somewhere to send data to first, right? So let me show you all the things that are running in this cluster. Okay, so hopefully you're seeing, and again, this can be very subtle, but hopefully what you're seeing and what I'm demonstrating is Kubernetes becomes a data center API. That's the marvel of it. That's the draw of it, especially to people like myself, right? I've seen the largest Splunk environments there are and the problems that are associated with basically running any kind of software in a large global data center, distributed fashion, blah, 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 right? Large, big distributed system, right? So the cool thing about Kubernetes in general is that I can see my whole data center, right? This is my data center is just one node, but it could be 20 nodes, it doesn't matter. I can see all of the workloads that are running on this data center or in this Kubernetes cluster. And so you can see there's my Splunk pod, which is my standalone Splunk instance that the Splunk operator is in charge of. So this operator is going to help us as Splunk admins or users deploy environments, Splunk environments, in a repeatable and in a code first way. Okay. Now we also have a bunch of other products that are also run in Kubernetes these days. Here is good old Splunk Connect for Kubernetes running. I also have the Signal Effects Smart Agent running. And by the way, this is being pointed both at my Splunk infrastructure monitoring instance that I teased up front, but also it's sending to my Splunk instance. I'm not sure that many people even know that that's possible, but I'll cover what I mean by that in a moment and show it to you when we get that Splunk instance back up. But that's just a little tour. So I just wanted to take you on a little tour of the environment. Again, I just want to set the stage. And now we're just going to go play a little bit and go into, as a Splunk user or as an administrator, how we can use this operator or what I was tinkering with there to deploy Splunk to the cluster. And as you can see, just showing you again, like this node's been up since about last Christmas. And so I'm going into Christmas this year, going to upgrade it, revamp it, kind of do another pass at it. So yeah, let's go break it a little bit. So I'll take a pause here. Now that I've set the stage and kind of shown you like what we're working with, I will dive in and I'm going to try and deploy a new version of Splunk 8.1.0.1 to replace this broken one that's not coming up right now, just to show you guys some of the innards and like what it's about. But I'll take a pause here. Any questions so far about the Splunk operator and it's I know it's a lot of info, but the general idea of, or the allure of why this might be interesting to some Splunk users? I'll just pause and take a sip if anybody wants to like come up for air or make any comments at this point. But basically, I'm going to go in and show you how to use it in a moment. So, any comments, questions? Anybody? Are you guys still with me?
Yep, still with you. This is cool.
Yes,
okay, cool.
Looks good. Just following along.
Mm-hmm. I am sort of interested in if you could just do like a 30-second. What is that ITSI service analyzer? That looks like a pretty neat tool.
Oh yeah, absolutely. Yes, absolutely. So this is just ITSI, and it's running a content pack basically that we made. Essentially, it's just a configuration that is doing one of the cooler things that ITSI does, which is like that dynamic entity and then template mapping. Mm-hmm. So this is actually dynamically mapping my Kubernetes environment. So and in a curated and thoughtful way. It's not saying show me all the things, because again, you don't want to fall into that trap, because that's like saying show me the whole data center. It's actually trying to just show us, okay, show me at a cluster, an infrastructure, and then a namespace level, so we can orient troubleshooting in that cluster to different app teams or areas, right? So you'll see like it's just custom KPIs. So for example, this one's alerting right now because in that namespace, we have just a bunch of custom KPIs, right? Like the number of pods that get created every minute, like the number of errors that are seen from the logs from Connect for Kubernetes, how many logs do we get? Because these can all be indicators of like, whoa, something's going on in there. And then if you jump into here, you'll see that we're just bringing in all the Kubernetes event data to show that, oh, in that environment, there's an open ticket because the vault pod, it has a readiness probe that's failed. Okay, so it's just showing you just some operational, like an example, and we can go into this in a bit. I just wanted to use it to just kind of tease like the visual environment so you guys see. But yeah, absolutely, we can go into kind of what is
really
powering.
Neat. And I don't want to take away. I don't want to take away from what you're trying to show today, but I just want.
No, I do want to show that definitely. If you guys want to talk about it, so but I'll let's come back to it in a moment.
If I jump in for a moment, I know there's some people here with more of the Kubernetes environment than the Splunk environment, and
okay.
For that, the ITSI, the IT Service Intelligence, is basically a premium app that Splunk sells. That some don't, some have, some don't. We don't. I think I've seen in one of the previous demos or maybe elsewhere that you can do some of this with Splunk App for infrastructure, which is what comes free, right?
Yep, and I'll show that too.
Okay.
I'll show that as well.
Thanks, guys.
I just wanted to show you this because for visuals and because and just to demonstrate the fact that, as you can see, I broke Splunk as I walked into this talk, which is the kind of speaker I am, right? Because that's, YOLO. That's the best talk. Let's go look at the broken one, right? So when you go in there, you can just see it's just simply reporting to me, look, somebody has done some changes in the environment. Obviously, something has happened. And you can go back and take a look at, oh yeah, Matt was in there messing with the operator so that he could show the people, so show the folks how it really works, right? So you can see here, it's just alerting saying, hey, your Splunk container, it's no good right now. It's not good right now, right? So pretty cool review. But let me just get it back into we'll go into some more of all the kind of things that we have as well, because by the way, this view here is also that same kind of map, and this has a 14-day free trial as well, right? So there's lots of free stuff I'll be showing you today that hopefully I can leave you with. This was just meant to orient us today, okay? We'll do a time check. So 12:30. I think I have the whole hour, so you guys just give me a time check in like 10 minutes, and we'll see where we're at. So okay, let's go play with it, right? Let's see if we can get that Splunk pod back up. Live the life of a Kubernetes operator and kind of see if we can't learn a little bit about the actual process of using this thing that Matt's kind of hand waving at. So again, the concept is pretty simple. You will deploy a Splunk built Jarvis. You know what I'm saying? Like it's basically Iron Man Jarvis. You want to come in and say, hey, I want a Splunk instance. It turns around and says, as you wish. And it takes care of all the things that are below it in the data center, because we shouldn't care about that anyway. We shouldn't have to, or at least that's the goal, right? And I'm an optimist, right? You got to be these days. So what I'm going to do is I came in and I updated the Splunk operator, and that's so you'll see that it restarted 40 minutes ago, and that it's running fine. And in this new world, the cool thing about it is we can inspect the resources that are running in the data center. So let's take a look at it. So kube control is like an API. It's like it's a client, right? So basically it's like any sort of like S3 command or whatever, just to talk to the cluster. So don't worry about that so much. It's just how I'm going to navigate around a little bit as we poke around here. But I'm able to do things like describe the pod called Splunk Operator, right? And so in Kubernetes, a pod is the lowest form of compute. It is not a container. They can be made up of multiple containers, but it's generally a single IP. Yes, you can actually add more now, but like in an idea, just to keep it simple, in the world of VMs, it's very similar to a VM in that everything that runs in that pod shares a networking namespace. Okay, and so here you have it. This is actually the Kubernetes operator running on Matty Mo's lab, right? You can see that it was started Thursday, December 20th at 11:50. Right? I love chaos, right? We got to right before the event, and so you can see that it has this. You start to see the complexity of what Kubernetes is doing, and I hope that I leave you with the idea if you didn't know what Kubernetes was, and it sounds like you have a lot of people that do know what it is. So I don't want to make this about Kubernetes, but if you don't know what it is, it's scheduling our workloads for us. Like I said, I don't care where it runs. I just want it to run, right? And so you can describe what is running. You can inspect the kind of container that is being used to run, the status, all those kind of things. It gets really deep, but I just wanted to show you that under the covers, the Splunk operator is the first thing that gets deployed into the cluster. And then once it is deployed into the cluster, you can deploy Splunk instances. So I'm going to show you, hopefully, I'm going to fix it right here. I'm going to show you how I originally deployed that Splunk instance. So after I had deployed the operator, the Splunk operator has what are called custom resource definitions. So let me go back to the documents, because definitely start at the FAQ, definitely start at the README. But then the next best place to go is into this part here, custom resources, because the operator pattern that I alluded to earlier is basically a collection of custom resources that we are making to represent key functionality in Splunk architectures. Okay, so you will see a couple of different custom resources that have a bunch of common settings. Okay, but for now, I'm just going to walk you through some of the CRDs, or what they call CRDs, custom resource definitions. So we have the following custom resource definitions: standalone, license master, search head cluster, cluster master, and index cluster. There's also one for Spark node, but we're not going to get into that today, but it's there if you want to mess around, if you want to get really deep with it. And so, well, what does that mean? Well, what it means is that the operator has allowed us to boil down these key Splunk validated architecture concepts into automated custom resource definitions, such that as an administrator or a user, I can just ask the operator for one and give it some parameters, or I can give it no parameters and just take what it gives me. Okay. I'm going to go into a few of them, but for now, I'm just going to worry about the standalone as I show this to you, because again, all of these are the same concept. It just layers more and more automation and complexity on how the operator wires all those things together. And I'm glad to go through them with you guys, but it's a long, deep journey into the pit, right? So if you try it and then you get stuck with any of those, let us know and we'll take it up in the Slack chat or something, right? So I'm going to pause. Are we good for time? We're good for time, right? I'm motoring along here. I got okay, good.
We got
okay. Okay, excellent. So I'm going to show you that my Splunk environment that we're hopefully going to go get running here again is a standalone instance, but lots of obviously the customers I work with today are deploying full-blown clusters. So the entire thing, or maybe starting with the search head layer, or maybe messing with the collection layer like heavy forwarders, etc. You'll see this repo does not go into collection. This is about building the core Splunk componentry. A collection is something I see hopefully coming in here later. You could imagine one for like, Kubernetes collector, universal forwarder, whatever. But we can talk about that later. But I don't. That's out of the scope of what this project is doing currently. Just so everyone's aware. Separate topic, right? So again, definitely have a peek through here. See that, you know, literally we have reduced the ability to instantiate cluster masters or clustered environments by simply just a YAML that provides some key pieces of information. Okay. And so let's try it. So here is my standalone configuration. This is the last known good that I deployed. I was running 8.05, and you can see I'm actually running a custom container image, which is basically just Splunk's image pulled down, and then I side loaded a bunch of Splunk apps into it. Okay. Don't get scared. That is not how we're gonna tell you to go do that. It's just that for development purposes and for like home gamers, it's just mad easy. And it's actually probably the easiest way to do it. I will pause here because we'll go through some of the feature set before we go away, because one of the hotter topics that I'll talk to you about is app management, right? And as you can see, this starts to get into things beyond just standing up Kubernetes. It becomes day 2, day 10, day 300. How do you take care of Splunk on day 300? Because that's where my Splunk is. It's on day 300, right? That's really where this stuff starts to get really interesting, right? So you can see for the seasoned Splunker, you're probably already understanding what's going on. You can see that I'm running a certain version of Splunk. I am giving it some persistent disk for the etc directory, which is where Splunk stores a lot of its configuration, as well as the var directory for where a lot of my standalone basically is going to index buckets. Okay, I could also set up Smart Store here, but I'm not going to right now. I don't personally yet. I'll show you. I have mini IO in the cluster because obviously that's a really cool lab to build, and that's where I'm going on Christmas time. So I'll give you a little sneak peek. But as you can see, all the configuration items that are available in this YAML are on that in this custom resource definition. Sorry for the scroll, but you'll see like common specs for all kinds of resources. You'll see like these are common for everyone, right? So license, where is the license master if it's external? Where is the cluster master if it's external? How much disk? Where should I run it, etc. Okay. Any questions on this so far? Cool. So I'm going to give you a repo with all this, by the way, so you can try it. So I'm going to do it live right here. So that's my last known good. Obviously, I broke my Splunk environment because I was upgrading the operator. Obviously, we're in beta, so that won't happen generally when we're in GA. But again, this is I was running a 1.0 version. A 0.1.0 version, and now we're going to 0.2.0, which is the current public beta. So I am going to share this config in a GitLab repo that is going to be called UG Boston December 2020. I'll make sure you all have it. It is internet routable, so if you just go to like maddimo.io/code/maddimo. You might not be able to do that actually because that might not be public, but you'll see that, like, for example, this is like the last talk I did for a Toronto user group, which again is totally valid still. It's just another version of this talk, and if you're getting started for the first time, this might be a good spot to start. But I will also add the Boston one in here so you can mess with both of them. Anyway, let's get back to it. I just don't want you to get lost or feel like you have to worry about any of this. So what am I about to do? Well, what I'm about to do is, what have I done so far? So first, like I said, I started this talk by saying this all starts with the Splunk Docker image. And so why I said that was because you can't do any of this without the Docker image, right? The Kubernetes operator, it simply runs the Docker image. It does, and the Docker image is where Splunk D lives, right? What I have done is I have a demonstration that, again, I'll leave behind for you, is I've shown you how I am sideloading those applications that I want when my instance spins up to be loaded, and the Docker file that's required to create that. And so all I did before coming in here was I created a very simple Docker file that's based on Splunk's latest image, which is 8.1.0.1. You can find it on Docker Hub. Again, I'll give you a bunch of links to get through all this stuff. I'll just give you the piece of knowledge that the Red Hat universal base image is what we build Splunk on top of. Okay. Obviously, we're doing that to try and stay ahead of CVEs and have the best OS layer at the bottom, underneath us as possible. In theory, you could run this anywhere, but that's what we ship. Okay. I'm also just seeding some apps, right? And now app install, we'll talk about that in a minute. There's a couple cool ways you can install apps in this Docker Splunk world. I can sideload them like this and point the Docker image to those apps, or I can even pull them down from something like Artifactory as the container spins up. So some really cool auxiliary functionality that you can see we can start taking advantage of in an environment like this. And then I'm just creating what we call a default.yaml, which is basically where Docker Splunk stores all of the, if you're a Splunk admin, this is where all of the kind of supported environment variables can be overridden. So you can see here, there's everything, like you can go down a huge rabbit hole here, as is such in Splunk, right? You can set things like, installing Java versions alongside, where are your apps? What kind of hex tokens do you want? All sorts of different things that you can put in here that would affect the way that Splunk behaves when it comes up. Okay, but it is not required and actually is not needed. It's because, again, we're trying to reduce the barrier to entry for people. So it runs with sane defaults. Okay, so I built that Docker image and then I pushed it up to my GitHub repo. Sorry, my Docker Hub. So again, I have plans to, send you a summary. Anyway, I'm not logged in, but I'm hosting a Docker image on Docker Hub under my Docker Hub. And basically, like I said, it's just that Splunk image that we're now going to try to deploy to Kubernetes. So let's try and do that. So now I have a Docker image that I want to deploy. What I need to do is I have to have I need to have some sort of manifest, like a deployment. So like if I say standalone.yaml, we need a very simple definition of what we want to deploy, right? And again, on the GitHub repo, if you follow the docs, you'll get a nice little kind of sample definition. I'm just going to steal one of mine. One moment as I go grab it. It was in and so what I'm going to do is I'm going to take that deployment and I'm going to replicate it here and try and get it running here, hopefully. And I'll pause for some questions while I'm doing that. Let everybody breathe for a second. But what we're going to do is we're going to take this YAML. Let me get back here. Here we go. Okay, so a Splunk YAML, very similar to this, right? And we're going to use it to say to that operator that's running in the cluster, hey, I want you to deploy me a standalone, with these labels, it's Splunk, it's running in Milton, it's using this image, and I want you to mount these volumes with these apps, okay? And install these apps when you wake up, okay? That's all this image, this YAML is really doing. Let me go back and try and redeploy. I'm going to grab my last known good. And as I bang away here, I'm going to deploy my Splunk instance, and then we'll log into it, hopefully through splunk.matimo.io, and then we can go into some of the more advanced config. But as I stop to try and deploy live and tempt the demo gods, any questions so far? Okay, so let's go back.
We're not asleep, we're mesmerized.
No, I'm sure. Don't worry. Kubernetes. Okay. So what I've done is I've come into that UG group, which I'm going to share later. Don't worry. And I'm going to go into that standalone YAML, and I'm going to paste my definition. Okay. I'm going to update it because I updated my container image. So the image is actually 8.1.0.1. Okay. And yes, in this future, this is how easy Splunk upgrades should look. It should just be flip the bit on the image, bang, roll it out. You know, tempting you yet? You know, that's only the first thing, right? Like, never mind all the, you know, the operational window that comes with things like that. You know, but anyway, we'll get to that. So I'm also going to change the image pull policy to if not present, because the Splunk image is a big one. So you don't want to really be lobbing that around the data center. You usually want to have it kind of cached locally. And once you download it once to the node, you don't really have to do it anymore, right? So in the environment. Okay, and then I'm just going to do a quick check because I did a couple upgrades of the apps that were being installed as well. So you'll see here, somebody asked about Splunk App for infrastructure. Yeah, version 2.2.2. Add-on for infrastructure needs to be there on my standalone. Yeah, latest, right? TrackMe, wicked app. If you don't know about TrackMe, get it. It's a great app for letting people use data easier in life. So, and then you can see I have Python Scientific for machine learning toolkit, and then machine learning toolkit. I've also got the semicircle donut chart, and I can see I'm missing one thing. I'll go back to my Docker image just to make sure the apps line up. Can't forget the emoji app, man. Come on, you cannot forget that. So I'll go add that back in to the manifest, so we make sure that when Docker Splunk wakes up, it will install all those apps that are on the actual image. Okay, so I'm just going to add that here. Did I miss it? No, there's no emoji app here. Let me add it. So as you can see, this is another amazing functionality brought to us by Docker Splunk and Splunk Ansible, which is what powers underneath Docker Splunk, right? But it will allow you to install apps dynamically from a location, like I said. And so actually, let me get that right. It was emoji 101. Okay, so I'll add that because, again, like I said, I've done it the kind of home gamer developer way, right? Like I'm just side loading it into the image so that I can just use it because I don't care, right? Like I'm just trying to develop, try to use it. Obviously, there's more enterprisey ways that we're working on this that might look like something like pulling from Artifactory or something like S3 buckets, who knows, right? But again, this is why I want to get you guys involved, because all this development is going on currently in the repo. So anything you see that you are interested in or want to weigh in on, by all means, you can follow along there. So I'm going to right quit this and YOLO it and see what happens. So in theory, it should be as simple as me saying, hey, Kubernetes, I've got a new order for you. So take this standalone image and apply it to the Splunk dev environment. I'm done. So I have now placed my order with the Kubernetes, big Kubernetes machine. It has taken my order and the operator has translated it into what to do the needful to reconcile this environment, right? And so let's see what this thing is doing right now. Now, because of the way I've laid it down, I might have to give it a little kick in the pants, but let's see what this pod is doing. So you see what I'm doing is I've asked the operator to reconcile, like to change my environment, update it. I want a new image. I don't want the one you have already. I want the new one, and I want these new settings, right? Because I have a couple new apps in there. And so now what we're going to do is take a look at whether this is why it's broken, by the way. It's I broke it during the upgrade. So what we're going to do is something you would probably never think that you would do in the old world, is I'm going to delete it as they gasp, as they collectively gasp. However, what I'm doing is I'm not completely blowing away the pod. I'm just basically hard booting it, right, to make sure it picks up any changes. And again, this is not what you would do. I'm just showing you because you're in my lab, and we can be a little bit more reckless as we learn. So I'm going to delete the Splunk dev pod, and we're going to watch it come up together. So, delete pod. Splunk Dev. Okay, now the beauty of Kubernetes is that when you delete something or you try to destroy something, it is a giant control loop, right? So it's just trying to reconcile, make it better, self-recover. And so what we're doing this for is to hopefully pick up those changes that I made. Generally, when the operator is GA, most of the operations you will do will not require you to intervene at all, right? You will make the request and it will do the thing. Sometimes you'll have to intervene because that's what happens, but we're trying to make it such that you don't have to touch anything. When changes come in, it just updates the operator accordingly. So I have deleted the pod, and so now we're going to watch it come up. So what, as you can see, it's like the Terminator. If I blow away a pod, Kubernetes makes sure that another one comes back to take its place. And obviously in a high availability situation, you'd have lots of the pods being load balanced too, so you'd never even notice. So for example, if this was a search head cluster, I could destroy one and you would generally not notice, right? Or an Index cluster, same thing. So we're gonna watch it come up. And then once it starts initializing, I'm gonna take a live tail of the Splunk Docker image so we can watch what it's doing. Also notice I run Istio, which is a service mesh. We're not going to get into that today, but you can see that's why there's like other pods deployed beside some of these, because there's a proxy basically in front of it. Okay. Okay, let's look at the logs. Let's see if it's doing anything. It's still initializing. So let's give it a sec. Gives me a good time to take a breath. Any questions so far, what you're watching here? Anybody lost? Anybody got any questions?
Is Istio a requirement for this? Because we're running an Ingress Nginx, so.
No, it's just a sample. Ideally, you will be able to. Nginx and Istio are definitely the ones we are playing with customers as we speak. But in theory, you should be able to do this with any networking layer technically. As long as you have like the ingress. And if you're interested in what the ingress is doing, I can obviously show that as well. But it's basically just like a load balancer sitting in front of Splunk.
Yep.
So we'll give that some time. Again, it's a heavy image. We'll see if it can get up. Once it starts initializing the Splunk pod, the actual magic starts to happen at the entry point. Again, I'll take a moment here to just level set. When you run the Docker Splunk image, right? Docker Splunk, all the source code for the build of the image and all of the advanced stuff is on GitHub as well. But it utilizes Splunk Ansible as the entry point. But again, that in theory, unless you want to help us develop or work with us, that's pretty transparent to you. Basically, just for the home gamers at home, I'm just letting you know that's what's making the environment variables that we pass to the container happen, making them dance, basically, right? So come on, baby, let's see what's wrong with it. Worst case, I'll just delete it completely, blow it away, and we'll do a new one before we get out of here. Give me 2 minutes because I know we're coming up on the hour. So Splunk dev describe pod. Yeah, okay. So it might just take a minute. So we'll give it a moment to run. If it doesn't come up, what I'm going to do is I'll just blast it away and we'll run a fresh one. But it also might take a while. So anyway. Ideally, what would happen is the pod comes up and Splunk is available at the Splunk endpoint. And so again, if we look in the Splunk dev cluster inside and I say get service, you'll see that the operator is also managing all the service wiring for me as well. So basically it's building the services required to expose the cluster, whether it's a search head cluster, an indexer cluster, a standalone, a HEC endpoint, S2S, all of that will essentially travel through whatever supported ingresses we generally end up tackling. Which again, like we said, if we go back to the good old Splunk Operator repo and into the docs section, you can see some of the early work we've done on ingress here. So you can see an Istio example as well as an Nginx example. Okay. Let's see if we can get this thing to come up and wrap it up. Come on, baby. Oh, okay, good. An error. Why not? Let's take a look. what we'll do is we'll just give it a real hard kick here. So. Oh, a probe failed. It's actually normal. So yeah, it's funny. It's part of the Istio stuff. We'll give it a second. Usually it crash loops and comes back. If it doesn't, I'll blow it away. So at this pause, again, as you can see, what I wanted to really just kind of introduce you to is a standalone deployment of Splunk that you can start playing with locally on any sort of like Ubuntu VM. I'm running all this on micro K8s, micro Kubernetes, super easy to use. You could run it on EKS, OpenShift, et cetera. It's all the same to us, to be honest, underneath. The actual thing that I wanted to get you to do was just to get comfortable with taking a look at some of the configurations that we are exposing to the administrator. So again, like, you want to just go look through those custom resource definitions and a couple examples that I'm going to leave behind and see if you can get yourself spinning on a standalone. And then obviously you can move up to deploying large environments as well. I will say though, that is not a practice for Docker desktop. That you will melt your desktop. Like, don't try and run a 7-node cluster on your desktop. It's not going to work, right? If you got a node like mine, you got 24 cores, sure, you can get away with a lot more. But again, remember that the Splunk Operator project at its core is building for cloud data centers, not really like, it's not trying to like solve all the problems for every Splunk admin on the planet, for sure, but it's trying to not only make the barrier to entry to running Splunk easier, but also bring Splunk to other development communities that might not want to have anything to do with running Splunk, but actually still be able to get the benefit of it. And so check out OpenShift. If you got, hey, look, it's running. So yeah, time's coming up. Look, we're right up on the buzzer. So if you have to leave, definitely jump. Again, thank you for coming, but I'm going to let this run so you can see what it's doing. And then if anyone has any final questions or items that you want to chat about, now's the time. So we'll show you what the magic of that Splunk Ansible endpoint is doing. Oh, did I break it? Yeah, I probably broke it really hard. But anyway, what you can see here is when that pod comes up, or when I eventually do get it running.
I don't think you needed the -f in that last command.
Oh, yeah, it's just for a follow tail.
Okay. I was thinking.
Yeah, I think I broke it. I broke my container, right? Which is no big deal. It's part of the, part of me deploying, but I'm going to try and delete it. Time's up. I'll get it working. And then I'm going to post the steps to get it working on the project for the Boston user group. And I'll make sure we send it out as a summary. But basically what it's going to walk you through is essentially building a Docker image that has some apps in it that you want, and then a deployment where you deploy the actual Splunk operator to Kubernetes, and then you deploy a Splunk instance to Kubernetes. Okay. Yeah, let's end there. I mean, I know it's broken. I wanted to get it working for you, but hopefully I covered some of the instruments. Like you will want to go check out the Splunk operator repo. You'll want to go check out the Docker image. And then I will post the walkthrough to get a working one, I promise, and you can try that. So anything else, any questions or any other items? I don't want to hold anybody late, but I can kick around. It's not a rush for me, but if there's any questions or items as you're leaving or that you've seen here so far.
Yeah, thanks, Matt. Thanks everybody. If you have to drop off, sure, everybody who wants to stick around. Great. Just for setting future topics, join the Boston channel in the user Slack, and we'll see you around.
Cool. I'm gonna see if I can quickly fix this in 2 minutes, but I'll stick around in case anyone wants to speak up. But as people drain out, thanks for coming, and yeah, reach out to me on Slack if you have any other further questions. So,
and hopefully Tom doesn't have a 1 o'clock meeting that he needs his Slack.
No, I'll drop in a minute here. I'll drop. You're right. You're right. Let me just try this one last Hail Mary.